Mr. Fun is trying to program a robot to travel in a triangular path. Here is his program, and let's determine if it will accomplish the goal. Use models to show your thinking. Forward, right turn, forward, right turn, forward, right turn. So we need to have a starting point, and we need to go forward 3 feet. So let's assume that the distance from those 2 points is 3 feet in proportion to how actual the size it is. We then need to take a right turn 120 degrees and go another 3 feet. We need to take another right turn at 120 degrees and go 3 feet and make 120 degrees at our next spot. When I look at my protractor here, if I were to rotate it and place it on my triangle and line up, rotate it a little bit here, kind of make it see-through for us, I can see that the degrees are 120 degrees since we have to line our straight line up here and go 120 degrees this way. So this angle here is 120 degrees. We can deduce that there are 360 degrees in a triangle since all of their angles add up to 360 degrees. He's also trying to program a robot to travel in a square path. Here is the program. Will it accomplish the goal? So we need a starting point. We need to go forward 30 centimeters, take a right 90-degree turn, forward 30 centimeters, right 90-degree turn, forward 30 centimeters, and right 90-degree turn. We know that, first of all, a square has all sides that are equal. We also can deduce now that there are 360 degrees in a square, since if we add all of their angles together, 90 plus 90 plus 90 plus 90 will give us 360 degrees. If a circle has sections that equal 1/4 of the whole and 1/8 of the whole that are shaded, how many degrees would the angle form in the unshaded section measure? So we first start with a circle. I'm going to separate it into 8 parts. Because remember, when we want to compare, I can compare 1/4 and 1/8 in terms of 1/8 units. We know that there are 360 degrees in a full circle. However, we have divided our circle into eighths. So we need to determine how many degrees are in each section. So I'm going to take 360 and divide it by 8 using our partial quotients. Well, 320 is 8 times 40. When I subtract, I have 40 left, which I know is 8 times 5, so I'll have a remainder of 0. Remember, we add up the parts that we multiply 8 by, so it's 45. So each eighth is 45 degrees. The shaded portions are 1/4, which we know is the same as 2 copies of 1/8, and 1/8 for a total of 3 copies of 1/8, which are shaded. Let's let the plus signs there indicate the parts that are shaded, which means there are 5 copies of 1/8 which are not shaded. So 5 times 45 degrees, going ahead and decomposing our numbers. So 5 times the tens, which is 40, plus 5 times the ones, which is 5, 200 plus 25 is 225 degrees. Let's expand this into an application problem. Daniel was so excited to go on the Ferris wheel until it stopped moving. Let's help his teacher decide how far Daniel got so that he can fix. Daniel's green carriage moved to the position of the yellow carriage when it got stuck. In order to get the Ferris wheel running, the operator needs to know how much the carriage has moved. How could we determine how far the carriage moved? Well, this is a circle, and a full circle rotates 360 degrees. Danielle has moved 3 carriage spots, and there are 12 carriages altogether. I will take 360 degrees and divide it by the 12 different sections that our circle is made up of, which is 30 degrees. So each section is worth 30 degrees. And since he moved 3 of those spots, 3 times 30 gives us 90. So Daniel moved 90 degrees from his original spot. The rotation of an angle is measured in degrees. An angle is created when two rays intersect at a single vertex. The size of the angle is measured in degrees. Angle B measures 55 degrees. We are trying to decide if the measure of angle A is greater, the same, or less. What do you think? Angle A is larger since its rotation is larger than angle B. Homework. You'll need a protractor for this activity. Draw an angle that measures 60 degrees like the one shown below. Draw another angle that measures 25 degrees. It should have the same vertex and share side BA. How many angles are there in the figure you drew? What are their measures? Make a copy of your 60-degree angle, draw a different angle that measures 25 degrees and has the same vertex and also shares side BA. How many angles are in the figure you drew? What are their measures? Scan and upload your work to the Make an Angle discussion board and respond to 2 of your classmates' posts. Moving on to geometry. We need to be able to draw points, lines, line segments, classify 2D figures based on parallel or perpendicular lines, and recognize lines of symmetry. Walking through town, you look at your map and notice many things learned in math class. Take a moment to pause and identify the geometric figures that you see. I see many things. I see squares, I see semicircles, I see triangles, I see rectangles, I see circles, amongst other things. We can also see angles all over town. So I've circled them in red. And further, we also can see parallel and perpendicular lines. I've circled them as well. While walking around town, you take a bunch of photos and you want to organize your images based upon the pictures. How might you group them? You can identify points, line segments, lines, rays, and angles. Geometric figures can be made from lines and line segments. So you may have grouped them by sorting by color, such as yellow, brown, or any other color that you see. You could sort them by shape, such as circle, rectangle, and parallelogram. Or we could sort them by parallel or perpendicular lines. 2 lines are parallel if they are on the same plane and will never intersect, and perpendicular if they are on the same plane and intersect to create right angles. Parallel lines must remain equal distance apart, such as the blue lines listed, and perpendicular lines must create 4 right angles. Let's look at the letters MATH. Use the vocabulary words intersect, parallel, and/or perpendicular to describe the lines that make up the letters. The letters T and H have perpendicular lines. The letters M and H have parallel lines. Only intersecting lines that are not parallel nor perpendicular are contained within letter A. For your homework, draw at least 2 examples and 2 non-examples of each of the quadrilaterals defined below: parallelogram, rectangle, and rhombus. Then I am a shape that is a parallelogram, a rectangle, and at the same time a rhombus. So I am all 3 shapes. What shape am I? Draw a diagram what I look like. Use the vocabulary words and their definition given above to explain what shape I am. Scan and upload your drawings and explanations into the What Shape discussion board. Comment on one classmate's drawings, ideas, thoughts, or arguments. We know how to classify triangles based on its angle measurements, but what about lines of symmetry in triangles? Take a moment to draw the lines of symmetry on this triangle. I can see that I can use each one of its vertex to draw a nice line of symmetry where if I were to fold on that line, I would get the same shape on both sides. Notice that all three angles are the same. They're all the same. They're equal. And we have three lines of symmetry. Draw lines of symmetry on this triangle. I can draw a line of symmetry down the top, from the top vertex through the bottom. However, if I were to draw a line from this vertex across, if I were to fold that, it wouldn't quite be what it should be to fold it because it wouldn't be the same shape. This triangle only has two equal angles. These are the equal angles here and here, and that we only have one line of symmetry. What about this green triangle? I don't think I can draw a line going from this vertex down, or this vertex across, or this vertex across. Notice that we have no equal angles and no lines of symmetry. Lines of symmetry can be used to create mirror images in figures. A line of symmetry that divides a figure into two congruent figures, each of which is the mirror image of the other. Homework. Print the practice homework provided in the practice homework Dropbox. Complete the problems provided, scan and upload your documents back into the appropriate Dropbox. Next week, we start grade 5.